So, I will give you a bit of a warning right up front. There is inherent in this conversation a certain amount of commercial messaging to it. So, I don't intend to offend, and I'm sort of giving you fair warning up front that that's in there. But there's also some good information, even if you decide to never try Respoke. So, I'm Steve Sokol. I'm the product marketing director for Asterisk now in Respoke at Digium. I'm also one of the co-founders of the Respoke effort. Respoke was actually started as kind of an internal startup within Digium, and we piloted it over the last 2 years, and it's been in production for about the last year. So we'll be talking a little bit more about that as we go forward. But in general, Respoke's mission in life is to do exactly what Danny was talking about, to enable integrated communications. Communications that happens inside of an application and inside of the context that has already been established by whatever you're doing with that application. We think that that is, as Danny kind of alluded to this morning, the key point of future communications. Whether it's from a browser or a native mobile application or a desktop application, it doesn't really matter. The key idea is that communications should be richer than just a phone call, caller ID, and whatever you can get across DTMF. So, unless you spent the last couple of days in the bar, you've probably heard a lot about WebRTC already. So you probably already know that it is the key technology to sort of opening this up, to making it possible. And the idea, of course, is that by incorporating a media engine directly into either a browser or an SDK that goes into native mobile applications, you have the ability to address a much larger audience of developers than you can with sort of low-level core technologies like Asterisk and Chameleon and FreeSwitch, et cetera. Everybody here in this room has already overcome the learning curve or is in the middle of overcoming the learning curve for this. There's a lot of people out there who are very much developers, very strong developers, but are not developers at the same sort of level that you guys are. They view things as, from a web perspective. They're accustomed to working in environments like Heroku. They're accustomed to not having to deal with infrastructure, with actually installing libraries and compiling and things like that. So this is an attempt to sort of establish communications as something that's approachable not just by the select few who understand SIP, but by a much broader audience. So you probably have heard a lot about how easy WebRTC is supposed to make communications. And it does to some degree. In fact, yesterday in the panel that I was on, we talked about this a bit. And anybody who's a competent developer can learn to do WebRTC in its native form. And anybody out there who's really interested can build the entire stack of stuff that's required to make it work. But I wouldn't describe it as trivial, and I wouldn't describe it as something that most businesses are going to want to take on, especially if their goal is simply to communications enable some component of their application. Now, if you're building something where the core function of the application is communication, then it's absolutely required that you learn all of the things that go into this. There's no shortcuts there. But if you're trying to add communications as an adjunct feature onto an existing application, you really have some interesting options that have come along. Now, for everybody who goes, yeah, WebRTC, that's easy, let's kind of talk about what goes into making WebRTC work. Because the browser and the media engine and the peer-to-peer networking engine that are built into the browser are really just one component of it. So here we've got our web developer who's starting in on this journey. And so we're going to use a word that he's probably not particularly familiar with, transport. So you have to be able to transport SDP, offer-answer messages, back and forth between web browsers. Those web browsers are usually connected over HTTP, which is a request-response protocol. The web browser requests it, the web server returns it. That doesn't work very well for doing bidirectional signaling. So something else is going to have to play the role. Now, you can fake that with Comet or Ajax, but that's rather an expensive operation. So there are new technologies which really make it a lot easier. So WebSocket is the thing that comes along. So our web developer goes, oh, yeah, OK, we'll get Node.js and we'll throw Socket.io on there, and we've got the problem solved. Well, OK, you're getting there, but you also then have to understand that there's signaling involved. And the most simple of these, of course, is the offer-answer process of sending an offer saying, hey, I want to communicate with you, and here's the big blob of SDP that Tim Panton was so offended by yesterday, and then sending a response back. And those are the basic messages, but there's an awful lot of other things that if you've looked at communications go into it. And even if you want to just deal with peer-to-peer WebRTC calling, there's a lot more to it. If you want to actually amend the way that call is going, if you want to add an additional media stream, if you want to remove a media stream, if you want to, say, throw screen sharing into an existing voice and video call, then you're going to have a protocol that renegotiates that call. So you have to have some kind of signaling protocol and some kind of signaling engine running on the back end that can follow and make sure that the signaling message process is going sanely. So, okay, our web developer spends a little bit of time and he figures out that, and he bolts something on top, and he bolts something into the browser library that he's building. So now he's able to actually route messages back and forth. But who are those messages coming from and to? You need to be able to assign some kind of an identity to the participants in a conversation. Even if the identity is unknown web visitor X, you still have to be able to say, okay, this is the browser that's sitting out here at 10.44.71.3, and I want to start a session with that particular browser. So you have to be able to identify. So you have to find some way of binding an identity to the sockets that you're creating, and being able to let people use human-readable, normal identifiers rather than the socket IO address that you get from the connection to actually route those messages back and forth. So you have to have the identity layer. Okay, so you've got identity. You somehow layer that in, and then the thing you probably want to do is have permissions. So if you've got a large and complicated application, especially one where some component of the application is facing the public internet, and some other component of it is reserved for people who are known users. Maybe inside of a firewall, maybe not. It really doesn't matter. But you've got different classes of users within it. If you've set up an asterisk system, you'd handle this by creating separate contexts. You have to kind of be able to do the same thing and layer permissions into your WebRTC messaging signaling engine. So you then have to figure out the identity and what that identity maps to in terms of permissions. So you have to build that layer in as well. And granted, there are cases where not all of this is required. But for anything that's a non-trivial application, a lot of these things are. So we go up one more layer, and on top of that, on top of the identity, you actually have to have a discovery mechanism. So when I connect up as S. Sokol, and somebody else connects up as FuzzyBear99, we can discover that we're both online at the same time. You have to have some means of establishing that. So who is here? And it can be as much as who is in the application on a global basis, but it can also be who has an interest in this particular topic. So you have to have some sort of, usually a pub-sub mechanism for doing discovery. Who is here and who is interested in what? So you can build that in on top of it. Then you probably may want to layer on top of that presence. So the ability for all of your users to broadcast to the people that they share with, what their current status is. So you need to have some mechanism for saying, I'm on vacation, or I am on the phone at the moment, or I'm not. So all of that is another layer that gets put in on top of this. And then, since you're building something that's a modern communications application, you probably want to put messaging in there as well. We've already got the transport, we're already moving messages, we've already got identity, so why not throw in the ability to send a user-to-user message in the instant messaging sense, or even better yet, a user-to-user application level message, which updates some bit of application state on either side. Or, to take it even a step further, some message that's going from your servers to your clients. So you have all of these things that you may want to build in. You may want to tie this into all kinds of things that are outside of your core WebRTC application. There's a lot of different components that make this up. So those are the things that are sort of application-y. Now let's take a look at some of the things that we all have to fight with. NAT. Don't we all just love NAT? Aren't we glad that IPv6 hasn't quite made its way into reality yet, and that we're still trying to translate addresses for everything? Well, WebRTC has done a very clever job of working its way around that. There are, however, still scenarios out there, still old NATs from the 90s or the early 2000s, which are impenetrable, even with stun, turn, and ice. Or pardon me, with stun and ice. And that's where you need to have a turn server, or some kind of server which is publicly accessible, to which both parties are able to actually reach. So this is yet another element that has to go in there. And so if you're going to create a turn server, and you're going to put it out on a public internet address, you probably also need to tie that back into your permissions system, because you don't necessarily want somebody else's web browser routing 4K video through your AWS-hosted instance of the turn server. So there's another layer that you have to concern yourself with. And OK, we've done all of this, but we've done all of this talking about browsers. So pause for a second and go, oh, crap, it's a mobile-first world out there now. So while WebRTC was originally built for browsers, there's been an enormous amount of adoption in the mobile world. It does a great job of being a media engine in the mobile world, but that means that you have to do all of the things that you've just done, all of the client-side components, on both mobile platforms, both Android and iOS, and arguably possibly Windows Phone as well, and maybe there's some others that you could throw in there. But at a minimum, if you want to play in the real world, you have to have Android and iOS SDKs that allow you to tie that in. And those have to speak your signaling protocol, and they have to understand how to talk to your cluster, your back end. So once you have that, you're still not quite done on the mobile world, because then you have push notifications. So in the mobile world, your phone, when you bring up an application, it runs in the foreground only as long as you have it out. As soon as your phone goes to sleep, that application loses its network connections. And so if anybody tries to send an incoming call to that device, it's not going anywhere. So the way that Apple and Google have found to solve that problem, or to allow us to solve that problem, is to provide push messaging capabilities, so that you're able to then route a message through them to a single socket that they maintain to each device in the network that then says, hey, you've got a call coming in from XYZ on this application. And then you can swipe, open up. Your application comes to the foreground, it connects, and it actually establishes a real-time session at that point. So you've got to build that in on top if you want to build mobile properly. And then, if you have any need at all to communicate with the rest of your network, because remember, most of the business world is still tied into the PSTN, you're going to have gateway services. Either SIP gateways, if you're going to route from your core infrastructure into your PBX infrastructure, pardon me, from your web communications infrastructure into your PBX, or if you don't have that, you might want to route directly to the PSTN. So you'll need to have a gateway layer that's in there. Now, Asterisk does that, and we'll talk about that here in just a minute and how you can make use of it. But that may be something that you'll need. And then atop all of that, you'll, of course, have to add management. So far, we've described all of these pieces, but we haven't said how your overall system manages them. You're going to have an API that monitors, that provides you with events, that provides your back-end applications the ability to integrate. So if you're running Active Directory, you can tie into that. Or if you're running some other directory service, you can tie in. You probably want your server-side applications to be able to integrate with your client-side applications in other interactive ways. So you'll have to have this management layer that's been layered in as well. And then, if you're lucky, if you're really lucky and your application goes big, you'll need to have scalability. So you'll need to be able to take this and run it not just on a single application server, but perhaps on hundreds of application servers, or if you're really lucky, thousands of application servers. So you'll have to figure out a way to spread this all across a global network and keep it all in sync. So if you're in the communications business, I'm pretty confident that you'll be able to do this. If your job is to be a web developer, I have my doubts. I don't mean to belittle web developers at all, by the way. I've got a lot of web development time myself, and it is a challenge unto itself. It is trying to nail Jell-O to the wall as far as I'm concerned. But it's a different skill set than communications developers. So there's a couple of approaches that you can take, a couple of things that will solve this set of problems. And of course, you're probably already familiar with one of them. Asterisk does do WebRTC in some senses. WebRTC can do, of course, a lot of different things, voice and video and screen sharing and data channels. And Asterisk right now supports the voice piece of this, and we support it through SIP over WebSockets. So it's one transport mechanism, and it is one service. Now, there's going to be video in there eventually. And at the end of this, I'd love to hear input from anybody out there who is interested in trying to make this work as to what other WebRTC components we can build directly into Asterisk. But if you go back and look at that last stack slide, it doesn't have all of the elements that go into building a full WebRTC solution. So that's where we get around to Respoke. Now remember, I warned you ahead of time that there's commercial content to this, so here's the commercial. WebRTC isn't difficult, but it also isn't real easy. The stack that you have to create in order to make a real enterprise class or carrier class or global over-the-top application is significant. And so we've done our best to make it easy for people by eliminating a lot of the requirements that go into that. We've packaged them up in a way that makes it easy to digest, and we've built it in a structure where your server connects into Respoke to provide permissions, to provide control, to provide access, all of that control layer stuff. And your client applications connect in over WebSockets, and we handle the routing and the signaling, transport, the full mesh. In fact, I'll show you the slide over here that describes it. And we've buttoned it up in a way that we have SDKs for pretty much any environment you'll want. We have browsers, we have native mobile, and we have Asterisk. So Chan Respoke is the component, and I see at least one Chan Respoke victim sitting here in the audience. So we'll talk a little bit about that next. But the idea here is to simplify the process to the point where if you're building an application where communications is a feature, but it's not necessarily the reason that that application exists, this is going to be a whole lot easier. If you're, pick Walmart, and you want to communications enable the Walmart app or the Walmart website, you can do this without having to become a complete expert at all of those different layers that you saw in the stack. If you're an individual developer who are building a game, you can communications enable that game in a way that's a whole lot simpler than trying to build all of the elements that you need in that stack. You may not need the whole thing for your application. So now if you're a carrier and you're really looking to build this as part of what you're doing, we can probably help there too. That's one of those, we would provide you with your own instance of Respoke rather than using the public one. But we've really gone to pulled out all the stops in trying to build something that solves almost all of the core problems. There's a few things that are left. We're still working on multi-party video. We've got multi-party audio in place. And there's a few other elements that I'm sure people will bring to our attention as we go forward. But we've had good luck with people who've come to us, and we've had especially good luck with people who've been interested in tying the audio component of this back to their Asterisk. Also, we've had lots of interest in tying other pieces back to Asterisk. So to talk a little bit about the Chan Respoke component of this, Asterisk was the first open source communications technology to support WebRTC. We do a pretty good job with SIP over WebSockets and audio, but the other pieces that need to be put into place are the things that you'll find in Respoke. To kind of talk about what it is that's there right now, today we offer voice calling from Respoke to Asterisk and from Asterisk to Respoke. In the future, we're looking at doing video calling as well, one-to-one video calling. Also calling into conferences. So ConfBridge has the ability to relay video. So you'll actually be able to build basic video broadcast applications or video conference applications with that. Metadata transport is something else that's on our roadmap, so that if you want to send some additional contextual information from your web application into your Asterisk and on to, say, to your agents, you'll be able to do that. There's some primitive ways of doing that now, but we're working on better ones. And adding messaging directly in, because Asterisk actually has the ability to deliver text messages as well over SIP, and also to bridge into XMPP. So we'll be able to add support for that too, which gives you, a whole world of ways of adding additional application logic in. So Chan Respoke is not part of Asterisk. It's something that you can download from our GitHub page. So go to github/Respoke, and you'll find the Chan Respoke driver there. It's relatively straightforward and painless to compile make, install, the sorts of things you've probably done a million times building out an Asterisk system. Over time, we'll probably start to build packages for it as well, but it's still in flux. We're still adding features to it, and we're still looking for feedback on it. So that's the basics. I'll take a moment and do a quick demo. And of course, this is a conference with conference Wi-Fi, so cross your fingers. Who knows whether this will actually work? So to bring this up. I have built, okay, screen, where are you? An Asterisk application over here, and let's take a quick look. There are two files that really require configuration. There's respoke.conf, and it's structured a little bit like if you've played with ChanPJ SIP. There are bracketed contexts or sections that provide different values. So just like you'll see in ChanPJ SIP, there's a type identifier that's associated with each one. So we have a transport type, which says which transport we're using. In this case, we're using socket.io, which is the only transport that we currently have exposed to the public, but it's possible we could add additional transports in the future, raw sockets, et cetera. We have an app type, which ties back to the Respoke app. Now in Respoke, when you create your account, you can actually create as many applications into that as you wish. And an application is kind of a namespace. It boxes in a set of users and a set of functionality, a set of permissions all together. So this is what you use to tie to a particular application within Respoke. And then you actually define an endpoint, because Respoke thinks in terms of endpoints. An endpoint is typically a user. But it can be if you want something else, if you ever want to tie IoT sort of devices into this network as well. And here's where you identify all of the normal stuff. So codecs, you disallow all and allow MuLaw, since we're talking to Asterisk over a relatively low level. And Steve over here is grinning because he's going, where the hell is Opus? And you're right. So that will be hopefully coming soon. There are ways around it if you ever want to dig into it. And for each endpoint, you identify that the type is endpoint. You set the transport, and then that points to this example, or pardon me, points to this up here, which is socket.io. You also set the app, so you're actually controlling that separately. You don't have everything, just the way in the old Chan SIP configuration, you had enormous blocks for each device. This sort of simplifies it a bit, especially considering what we're doing here is creating templates. So then when you want to create something that is accessible over the Respoke network inside of your application, all you have to do are create some endpoints that are based on these templates that we've set up here. So we have a special case, by the way, which is the word anonymous. You should never create an endpoint that is actually called anonymous, because that is a reserved word in Chan Respoke. And that means anybody that we don't already recognize. So if you create an endpoint in Respoke, a web browser, some random web visitor, and you want them to be able to place a call into your Asterisk system, they will come in as anonymous, which just means an endpoint that we don't recognize, that we don't have a specific endpoint identifier created in Chan Respoke for it. So you'll see down here at the bottom, down at the bottom there, we create some individual endpoints. So to give a quick demo of this, and then I will let you grill me with questions, I'm going to come over here to a demo page. Let's do a quick refresh of it. I'm going to plug in the audio. And do we need to do anything to bring up the audio? You got it? OK, cool. And so now I'm going to have it call Allison and see what she has to say. You see it's activating the WebRTC. We'll come over here and look at our CLI, which isn't showing anything. There we go.
WEBCALLER.
So there we go. We've just had a web caller come through and connect with your Asterisk system. Very, very simple example, but in essence, once a call comes into Asterisk from Respoke, it's just another Asterisk call, and you can deliver it anywhere. If you want to drop it into a conf bridge, you can do that. If you want to drop it into a queue, you can do that. And of course, we're hoping that you'll do most of your management of it from the beautiful new ARI application or interface that we've created. So that's the basics of it. There's an awful lot that you can do. And I didn't mean to scare anybody with the enormous stack of things that go into building a WebRTC engine. But we've been through the process, and we now know all the things that it takes to build a full-scale WebRTC engine. So I appreciate your time. And at this point, I'm going to open it up for questions, and Ben can come around and...
Questions for Steve?
I've either done a great job or I've done a terrible job.
If you're using Respoke and you've a video chat going, and then you call into Asterisk, I assume then you can at least record the audio. Does it record the video as well?
It will not at this point. Now, that's something that will be coming along in the future once we have one-to-one video capabilities going through it. Video recording is surprisingly complex for Asterisk. I don't know quite why. I'll need to get Jordan to explain that to us all, perhaps this afternoon at the big open session. So, but you can record the audio because it's just more Asterisk audio at that point.
Google just announced in Chrome 47 the first experimental media recording APIs in Chrome itself. So, which in fact, oddly enough, supports video only and not audio, but I presume eventually you'll be able to get it all. So you'll be able to do it on the client side as well.
That's useful for casual applications, but any case where you actually wanted to create a record and you as the administrator know you've got all parts of it, it's a little bit different. And I'll be curious to see how well that works out in terms of actually creating, taking the storage and putting it somewhere on the local machine. So, anybody else?
This is a very basic question. I'm not familiar with WebRTC, but as a user, is there any browser compatibility issue you know of? Or is this very compatible for any browser out there?
WebRTC has its quirks here and there. By and large, there are shim layers that sort of make them say, Chrome interoperate with Firefox, et cetera. And we've built that into our libraries. So if you use Respoke, we've got what's called adapter.js layer, which actually takes care of translating out those little differences between the two major browsers. And we'll be doing the same thing for ORTC, which is coming in with Microsoft's recent Edge browser as well.
In your example, you just play audio, but when you connect the Spoke with endpoints with user, the Asterisk will do the transcoding and coding.
When you have to, but the browsers actually support MuLaw, and Asterisk should eventually support Opus. So you'll actually have a codec in common between them. Now, one of the things that'll be interesting is when we get the Microsoft world and the Google world all tied together through this, the possibility of adding transcoding for video in Respoke. So we would take care of actually translating back and forth there, so you're not having to layer that into your Asterisk system, because that's a significant CPU resource hog.
Hello. I'm looking at the Respoke sort of a licensing page. It says here, peer-to-peer usage unlimited. So it means, let's say 2 people connect, they can transfer video or calls peer-to-peer, right? But there's an entry here that says media relay.
Correct.
So what does that mean exactly?
Media relay comes into play when you have a NAT or a firewall that makes it otherwise impossible to create a peer-to-peer connection, just because of the way the network has been configured. In some cases, it's so drastic as to ban all UDP traffic or something. And in that case, we actually create a TCP tunnel to the turn server that I mentioned earlier. And all of the traffic gets routed through the turn server and back out to the other side. So there's sort of a meet-me point in the sky, if you will.
So, Respoke, you said it's not part of Asterisk. Oh, sorry. You said Respoke is not part of Asterisk. You guys developed that separately. But then, like when you say video conferencing is on the roadmap, which parts of it do Asterisk need to do versus you guys versus Resip versus Respoke?
Respoke it's compatible license-wise with Asterisk. It's also GPLv2. By the way, all of our client libraries are open source. So if you want to make use of them as they are, you can. If you want to take them and fork them, they're all MIT except for Respoke because it had to be license compatible with Asterisk, which is GPLv2. But what's in the Asterisk channel driver for Respoke is simply the signaling interpreter that then breaks everything down into Asterisk's internal structures. The media will flow in at that point, and it's up to Asterisk to actually take care of, for example, if you're doing the sort of video conferencing that's possible right now in ConfBridge, it is one presenter video. So you'll have one person's media coming in and being distributed out to everybody, and you can then pick who is the current presenter. That's all handled at the Asterisk layer through the ConfBridge application, or through the new conferencing, I guess, bridging engine, really. So.
Any other questions? Okay.
Very good.
Thanks very much, Steve.
Well, thank you very much.